Hello, my name is Esbern Patursson. I'm going to have a presentation on large smolts and sea lice. I'm working for Hiddenfjord, which is a family-owned business. It's these two brothers that own and manage Hiddenfjord, Atle and Regin Gregersen. And we are located in the west of the Faroes, where we have sea farming sites and processing facilities and a hatchery. We have a philosophy with some values and goals, but I won't go into details. And there we have our sea lice strategy. So sea lice is, of course, very complex, but first and foremost, we farm on exposed sites, which gives less sea lice. Then we have a short time on sea with large smolts and fast growth. We use lumpfish, a lot of strategy and planning and research, where we know the hydrodynamics and population dynamics of our sites. Then we lobby for appropriately strict regulations. So this is the production in the Faroes, which has been quite stable the last years, but around 70 to 80,000 tons. And here we have the production of Hiddenfjord, which has been growing a bit more and is around 18,000 tons. So we started with increasing the smolt weight in around 2010, and we have increased to around 650 grams on average now. And the growth is really fast on sea, as I mentioned. You see the TGC or VF3 here, and we are now at above 4, which is really fast. And the large smolts and the fast growth means we have a very short period on sea, so below 11 months on average in 2020. This means that the production time the picture has been flipped upside down since 2010 to 2020, where we used to have 10 months on land, we now have 20, and where we used to have 20 months on sea, we now have 10. This means that the production cycles are faster, and therefore over a period of time we have more fallow periods, which means we have a lower biological risk of diseases and so forth. So as I mentioned, the sea lice is complex, but it's usually divided into two population dynamics, an internal infection or an external. So the internal is shown with the dashed line, which has a slow growth and then has a slow start and then an exponential growth. And the external infection is shown as the black line, which has a faster start but reaches a steady state when the natural mortality of sea lice is the same as the external infection pressure. And then we have the combination of the two, where we can have both external and internal infection, which is the gray line, which has a fast start and exponential growth. So Tróndur Krakten has worked a lot with modeling sea lice using this theory. So I've played a bit with this model where I've made some settings where if a site comes to 1 adult per salmon, then we will have an automatic treatment which has an effectivity of 80%. Then I always have 1 million salmon per site and a constant temperature of 10 degrees. Then I can play around with the external and internal infection pressure, as well as the production time, where I've used a short one or a long one. So here are some examples. This is a site with low external infection and no internal. You see the steady state is around 0.6, so therefore there's no treatment. But reducing the production time gives less sea lice. Of course, we reduce it in the end, the start will always be similar. But if you simulate this over a 5-year period, you get 1 extra production cycle in the short production time. But even then, you have a lower total amount of sea lice produced. Another example with a higher external infected site, where the threshold or the steady state is above the threshold, therefore we have 2 treatments in the top one with the long period. But in the short period, we only have 1 treatment. And still we have fewer sea lice produced. So less treatments and less sea lice. If we try this over a 5-year simulation, we get again 1 extra production cycle, but still a lower total amount of sea lice and fewer treatments. So here's an example with an internally infected site where we had a slow start and then the exponential growth and 4 treatments in the long period. And the bottom with the short period, we get only 3 treatments. And again, a lot less sea lice totally. Yeah. If we try this one over a 5-year simulation, again, an extra production cycle, less total sea lice and fewer treatments. So lastly, I just tried a system with 4 farms that are connected, so they infect each other. And to the left, we have 4 farms with long production periods, and to the right, 4 farms with short production periods. Again, you get fewer treatments, fewer sea lice, and a higher production with the short production periods. So to summarize, you will always have fewer sea lice with a short production period, regardless of the dynamics of the site, and even fewer treatments. This is the same as we see on our sites at Hiddenfjord. This is our most problematic sea lice site, where we see the last 4 production cycles. To the left, we see that we have reduced the days on sea a lot, and to the right, we see that the amount of sea lice produced is reduced a lot as well, and the total number of treatments on the site. So if we look at Hiddenfjord as a whole, we see the average number of salmon on sea for us to the graph on the left is going down, whereas the production, the graph to the right, is increasing. And it's increasing a lot, it's almost doubled at the same time as we have lowered the number of salmon on sea. To the left, we see that mortality has also gone down, but the intensity of our sites has increased, so therefore we have a higher biomass on the sea, which gives more feed. So to summarize, if you produce large smolts and keep the same or even fewer salmon on sea, you will have an increased production, less sea lice, less handling of the salmon, and a lower biological risk with less disease and lower mortality. The only con is you will have a higher intensity of the sites, and we will have an increased pressure on the sediment. But here the solution, again, is exposed farming, where waves and current resuspend the sediment, and you will have a lower internal infection pressure, which makes it easier to handle the sea lice. That was it for me. Thank you.